Imagine this. You are standing on the edge of oblivion, where the laws of the universe twist into something terrifying and exhilarating. What happens with gravity inside a black hole? Is it the same gentle force that pins your feet to earth? Or something far stranger, something that could unravel reality itself? On our cozy planet, gravity pulls at a mere 9.8 meters per second squared. But near a black hole's event horizon, it skyrockets to over a trillion times Earth's gravity 10 to the 12th power Gs. That's enough to crush diamonds into dust in an instant. Buckle up, because we're diving into the heart of darkness, where fear meets fascination. But first, a question to jolt you. What if crossing that invisible line meant no turning back ever? Hold that thought, we're just getting started. Now, let's confront the boundary that guards these monsters, the event horizon. This isn't just a fancy name, it's gravity's unbreakable wall, the point where escape velocity equals the speed of light. For a black hole with our sun's mass, that's a tiny 3 kilometers across. Tiny but terrifying. Cross it and every possible path in your future leads inward toward doom. This isn't sci-fi hype, it's straight from Einstein's general relativity, the theory that redefined our universe. Feel that chill? That's the fear of the unknown kicking in. But what if I told you? Inside, gravity doesn't just pull, it rewires time and space themselves. Light chuckle. Okay, pause for a sanity check. If black holes had a warning label, it'd say, abandon all hope. And physics as you know it. But seriously, let's flip the script on reality. Inside the horizon, gravity pulls a mind-bending switcheroo. In our everyday world, time marches forward while space lets us roam free. But here, the equations reveal that the direction toward the center acts like time itself. You can't escape because moving outward would be like trying to rewind yesterday. It's inescapable, urgent, like a cosmic clock ticking down to zero. Excitement builds as you realize. This is gravity on steroids, forcing you deeper with every heartbeat. But hold on, what if that pull isn't uniform? What if it tears you apart from the inside out? Cliffhanger alert, your body might not survive the journey intact. Enter spaghettification, the tidal force nightmare that turns you into cosmic pasta. Near a stellar mass black hole, gravity's grip is so uneven that the pull on your feet could be billions of times stronger than on your head. Result? You'd stretch thinner than an atom, ripped apart long before the center. Fear that visceral horror? It should, it's gravity's brutal side unleashed. But here's the twist for excitement. Plunge into a supermassive black hole, like the ones lurking in galaxy hearts with millions of solar masses, and the tides at the horizon are surprisingly gentle. You might cross without a whisper of pain, only to face deadlier forces deeper in. Ever feel stretched thin by a deadline? Multiply that by infinity, yeah, black holes don't mess around. But what awaits at the core? Something that shatters our understanding entirely. Racing toward the singularity, now the point where gravity goes infinite. General relativity predicts matter collapses into a zero-volume point of endless density where space-time curves without limit. Infinities? That's physics screaming for help, a red flag that our rules break down. The fear is real. What if reality unravels? Yet, excitement surges because quantum gravity, the elusive fusion of Einstein and quantum mechanics, promises answers. But could there be firewalls or hidden horrors blocking the way? We are teetering on the edge of breakthrough or breakdown. The cosmic censorship conjecture insists singularities stay veiled by horizons, shielding us from naked infinities. But the firewall hypothesis? It warns of a quantum blaze at the horizon, incinerating anything that dares cross-clashing with relativity in a cosmic showdown. Then, there's loop quantum gravity and string theory, hinting gravity might rebound matter or spawn wormholes, turning black holes into gateways. Urgency hits. These aren't idle what-ifs, they're the frontier of physics, where fear of the unknown fuels our quest for truth. Imagine telling Einstein his masterpiece needs a quantum upgrade. Talk about a plot twist. Finally, the knowledge bomb to seal it. We can't peek inside directly, but gravitational waves from LIGO's 2015 detection and the Event Horizon Telescope's stunning images of Métis 7 and Sagittarius A offer tantalizing clues. So, what happens with gravity inside a black hole? It might just unlock the holy grail uniting relativity and quantum mechanics. Feel that rush? That's the excitement of standing on the brink. But remember, the universe guards its secrets fiercely. What if the next discovery changes everything?